Okay, this is the last section of hyperbolas, and then we'll go ahead and do parabolas in the next video. I just want to share a little bit about hyperbolas with you. First of all, three-dimensional hyperbola is hyperboloid, and I found this cool little demonstration in La Sagrada Familia, which is in Barcelona, Spain. Basically, if you take a cylinder, which is what was shown at the beginning, and you twist it around, you end up getting hyperbolas here, and as it unwinds, you end up getting hyperbolas here on the sides. So that's kind of a very cool way of seeing how a hyperbola relates to a cylinder. La Sagrada Familia was designed by an architect named Antoni Gaudi. And Gaudi, the reason I'm bringing this up is Gaudi actually used a lot of mathematics in the buildings that he designed. In La Sagrada Familia, he used hyperbolas to shape the columns. And the columns, interestingly, there was like 5-sided columns, and then there were 17-sided columns. And that was the highest amount of sides that the column had. And it's really, really interesting why he chose those numbers. These are the columns that I'm talking about, and this is the ceiling, actually, a very cool building. And the shapes at the top, again, are hyperbolas. And the reason that they're used is because they support the weight of the building a little bit more than if the columns just stood straight up. I have a little fact here about La Sagrada Familia that you're more than welcome to look up on your own, because it is kind of a fascinating topic on how math is applied outside of our context. We're going to be working with hyperbolas in the second degree equation. The way you're going to know if a hyperbola is if the equation of a conic is a hyperbola is if A and B have opposite signs. That's how you're going to know. So let's go ahead and do the same work that we did before. I'm going to go in and group all the terms. I notice that 16y squared is coming first, so I'm going to leave that first. And I'll have 16y squared plus 64y. I'll keep the x squareds in blue and the x terms in blue. I'm sorry, in green. And I'm going to have 65 on the other side of the equation. Factoring out to get y squared equals to 1, factoring out 16. And I hope by now, since we are a little bit into this unit, you know how to complete the square, I hope. So I hope my limited explanation here isn't killing you inside, and if it is, I am truly sorry, but you did have that opportunity to learn in the past couple days on how to do this process. And I warned you that we would be doing this, completing the square process over and over again. So again, if you don't know this yet, please get some help with it because it keeps coming up. Okay, this last part equals, we got 65, and it looks like we're going to have a 16 and 4, and I should have added this in on this side instead of reprimanding you. So we got 16 times 4, and we're also going to have a minus 1 times 1. So what that gets me all together, that's going to be 64, 63, and it looks like I'm going to get 128, which is a great number. And when I divide that over, I'm going to get 16 goes into 128 8 times. So I'll have y plus 2, and you could use a calculator for that part, over 8 minus x minus 1 quantity squared over 128 equals 1. If you forgot y divided by 128, please keep in mind the standard form of a conic will always be equal to 1 if we're looking at ellipses and hyperbolas. So this is our equation of our hyperbola in standard form. And now it's time for the fun part. And I know you guys are not going to be looking forward to this because this is the harder part, so let me just bring this stuff down here for you. Okay, our center. With the x value first, we have 1, comma, negative 2. For the major axes, I'm sorry, for the major vertices, since this hyperbola is standing up, and I know that because the y's come first, I'm going to be manipulating the negative 2 a little bit. So notice, first of all, that the a value is going to be the square root of 8, plus and minus. The b value is going to be the square root of 128, plus and minus. So my major vertices are going to be 1, comma, negative 2, plus and minus the square root of 8. My foci. About that, I had a little technical difficulty. My foci are going to be, again, in the y direction, so I'm going to have 1 comma, and then it's going to be negative 2 plus, now let's see what we have here for the foci. It's a squared plus b squared. And if I just scroll back up a little bit, I see a squared is 8 and b squared is 128. So I have 8 plus 128 equals c squared. That's 136 equals c squared. And I know that root can be reduced, but I'm not going to worry about that right now. So 1 comma negative 2 plus and minus the square root of 136. Please check with your teacher to see if they want you to reduce the square roots. I'm not too worried about that at the moment. And finally, the asymptotes. If you can picture it, and I'll draw a super quick graph here. If you can picture it, I have 1, negative 2, which is right there. My major vertices, I went up some amount, negative 2 plus root 8, and negative 2 minus root 8. This is your y distance. So I have my slope of this line is going to be negative 2. I'm sorry, my slope of this line is not going to be negative 2. It's going to be how much I went up from negative 2, which is just root 8. And then I'm going to divide that by how much I actually went over, and I went over root 128. Now, if you'll believe it or not, this actually does simplify to 1/4, because 8 goes into 128 16 times, and we're taking the square root of 16, which is going to be 4. So the slope here is going to be 1/4. That means the equation of my hyperbola is going to be, the equation of my asymptote is going to be y is equal to, for the two asymptotes, plus and minus 1/4, x minus 1, minus 2. I understand I went very quickly through that 1/4 part. If you need clarification, please check with your teacher. This is a lot of work, I know. I hope, though, that you did get through this part on your without any difficulty. Try this last problem on your own. Resume the video when you're ready to see the answer. Okay, so the solution. If you followed all your work and it looks correct and everything is mathematically correct as well, you should get x plus 2 quantity squared over 3 minus y minus 5 quantity squared over 4 equals 1. This looks like the hyperbola is going to be on its side and not standing up. And then analyzing it just a bit, our center is going to be negative 2, 5. Our major vertices, since again it's on our side, we'll be manipulating the x values only. We'll be manipulating the x values by our a value. So that's why I get negative 2 plus and minus the square root of 3. The y value for the center stays the same. Our asymptotes, it looks like I went up 2, because that's what my y value is saying. I went up 2 and over root 3, so that's why I got 2 over root 3. And the plus 2 and the plus 5 are just the coordinates for the center. And then finally, for the foci, I did a squared plus b squared, which really got me c is equal plus and minus the square root of 7. And again, since I am looking at just the x values because hyperbola is on its side, I'm going to manipulate just the x value. So I'll take -2, the x-coordinate of the center, and add and subtract root 7 from it. The y value for the center stays the same at 5. It's a lot of work, guys. Hang in there. I got 3 more videos for you. I think only 2, but possibly 3 more videos for you. And again, if you're having trouble with this, please seek the appropriate help. Thank you for watching.